Hi, Hari Om to everyone. Now in this session we are going to discuss about the electric potential due to an electric dipole. Actually it's a very important topic. Uh, we have already known something about the electric dipole. Actually in this question, in this topic, we are going to discuss mainly two important things. That is cosine law. Cosine law and binomial theorem. For cosine law is nothing but it is used to measure, to find the angle between angle of the triangles. For example, if we'll take, this will be the angle A and this will be angle B and this will be the angle C. And for my convenience, I am just going to take this is A and this is B and this is C. Okay. Now, according to cosine angle, okay, B will be equal to A squared plus B squared, minus 2AB cos theta. Okay, so by this way I can measure any of the line of the triangle. For example, I can measure A, B, C. And the next one, the binomial theorem. Yeah, we all will know that is A plus B the whole square. What is A plus B the whole square? A square plus 2AB plus B square. Okay, here I can come to know here, so the power of A plus B the whole square is 2. Okay, this 2 will be coming in 2 times, A square and also the B square. And look at the term of AB. Here the term AB, power of A is 1 and power of B is 1. So totally the total power will be 2. Right. Okay. Actually there will be a general formula for, that is A plus B the whole to the power n. Yeah, mostly the math students will be able to easily understand. That is according to the binomial theorem. We are having NCR, okay, and n factorial. By the way, it will be coming like sorry, A to the power n and B to the power 0 plus A to the power n minus 1 and B to the power 1, okay, plus etc it will be going. Okay, so these things I am going to use. Right, now come back to our thing, like now, so the electrostatic potential at a point due to an electric dipole. Here we have, this is the diagram. The diagram is very important. Now look at the charge minus q and the charge plus q, and look at the distance r1 and look at the distance r2. Okay, what is its meaning? Minus q is located from r2 to the point P, plus q is located r1 to the point P, and from the center the distance is r. Okay, now I am going to use the cosine formula. I am going to use the cosine formula. Okay, the potential at P due to the charge plus q is q by 4 pi epsilon naught r1, and potential at P due to minus q is minus q by 4 pi epsilon naught r2. And so the total potential at the point P is V is equal to q by 4 pi epsilon naught, look here, q by 4 pi epsilon naught 1 by r1 minus 1 by r2. And look, suppose if the point P is far away from the dipole such that r is very greater than A, then the equation can be expressed in the form of r. That is, now I am going to use the cosine law. I already told you, suppose if it is a triangle ABC, in this angle ABC, A squared will be equal to B squared plus BC squared minus 2BC cos A. By the way, okay, by using this, I am going to use the triangle BOP. R1 square is equal to R square plus A square minus 2RA cos theta. And if I take R squared as a common term, okay, now this term will become R square taking out 1 plus A square by R square minus 2A by R cos theta. And since the point P is very far from the dipole, R is very greater than A, as a result I can reduce the A square minus R square. It is very small, so I can remove it. So finally the R1 square will become, okay, R square within bracket 1 minus 2A by R cos theta. Now I need to know the value of R1, so R1 will be equal to whole to the power 1 by 2. Okay, right. Now 1 by R1 will be equal to 1 by R into 1 minus 2A by R into cos theta whole to the power minus 1 by 2. And now I am going to use the binomial theorem. So this is what I already told you in the beginning. So, and here you don't need to explain step by step. Simply you are just entering the term by using binomial theorem and retain the remaining term. Okay, retaining the lowest order and or neglecting the higher orders. Okay, now I will get 1 by R1 is equal to this value. Now, so the finally I will get 1 by R1 is equal to 1 by R into 1 plus A by R cos theta. Next, similarly I am going to use the same cosine law and also the term. Okay, simply I just want to know the value of 1 by R2. Okay, so I will get, okay, the binomial theorem I already told you. A plus B whole to the power n will be equal to n factorial by n factorial into 0 factorial A to the power n B to the power 0 plus n factorial n minus 1 factorial into 1 factorial A to the power n minus 1 into B to the power 1. By the way, it will be keep on extending. Okay, right. By using binomial theorem, 1 by R2 will be equal to 1 by R into 1 minus A by R into cos theta, substituting the value. Okay, so here when you substitute the value, you have to substitute carefully, because initially we have written V will be equal to, okay, we have written V will be equal to V1 minus V2. Okay, so when I substitute the value, here I will get 1 by R into A plus 1 by R plus A cos theta by R. Here 1 minus A by R cos theta by R. Finally I will get, so by substituting I can cancel plus 1 and minus 1. So finally, can you understand? So I can reduce this plus 1 and minus 1. 1 minus 1 is equal to 0. The remaining term will be plus A by R cos theta plus A by R cos theta, that is equal to 2A by R cos theta. Already I have one R. Here. Okay, finally I get 2AQ by R square into cos theta into 1 by 4 pi epsilon naught. Now we all will know that what is 2AQ. Okay, what is 2AQ? P is equal to 2AQ. So finally I can have, so by substituting P is equal to 2QA, I will get P is equal to 1 by 4 pi epsilon naught into P cos theta by R square. Now we can write P cos theta will be equal to, because cos theta will be always representing the the scalar vector, scalar product. Okay, so P vector dot R vector, when the unit vector will be to the point P. Okay, the electrostatic potential at the point P due to the electric dipole is equal to P vector dot R vector by R square. Now there is a special cases. Now it is containing, in this equation we have the term cos theta. So cos theta will be having different values from 0 to 90. When cos 0 is 0, cos 90 is cos 0 is 1 and cos 90 is 0. So by substituting the value for the various value, theta is equal to 0, theta is equal to 180 and theta is equal to 90. For the various value, we will be having various value. When theta is equal to 0, it is equal to positive value. So the point will be located near the plus q. When v is equal to minus, the point will be located minus q. And when theta is equal to 90 degree, so v is equal to 0. So what is its meaning? The electrostatic potential in its equatorial line will be 0. Okay. So this is a conclusion we have got. So these are all the important points. For an electric dipole, the potential vary by 1 by r square, but for a point charge, it vary by 1 by r. That is, the potential due to an electric dipole is greater than the potential due to a monocharge. Listen carefully, potential due to the dipole is much greater than potential due to a monocharge. So the potential due to a point charge is spherically symmetric. That is, symmetric means, so when I taken a point from a charge, okay, it will be same at all the points. For example, if I will be taken the charge here, okay, if I will be moving around the charge, either here, here or here, around it, okay, I can have the same value in all the point in the circle. So this is called symmetric. But in the case of dipole, it depends on the angle between the P and R. So that this is what we have already known. Okay, right. Now we are going to come to know another one conclusion that please wait, I will show you. Like so far we have discussed something like what is happening to the electric field, what is happening to the electric potential due to an electric dipole. So what are the conclusion we have got so far? See, I told you, see, due to the point charge, electric field E is directly proportional to 1 by r square. For an electric dipole, minus q and plus q, E is directly proportional to 1 by r cube. I am just recollecting those things. And for an electric potential V, for the point charge, V is directly proportional to 1 by r. And for the electric dipole, V is directly proportional to 1 by r square. Can you understand? So first one, for the point charge, E is directly proportional to 1 by r square. For an electric dipole, E is directly proportional to 1 by r cube. And for the potential V, for the point charge, V is directly proportional to 1 by r, but for the dipole, V is directly proportional to 1 by r square. Now we are going to simply discuss these things with the help of the graphic calculator. Now first I am going to write E is directly proportional to 1 by r square, or E is equal to 1 by r square. Okay, let me take 1 by r, or E is equal to 1 by y. Okay, so look at the graph. So this is what the graph you will be getting when E is directly proportional to 1 by x squared. Okay, so look at the graph. This is the graph. E is directly proportional to 1 by x squared. This is for the point charge. Can you understand? Now instead of x squared, I am going to write cube. Now look at the graph. So the previous one is for electric field due to a point charge, and this one is electric field due to a dipole. By the way, I am going to write V, the electric potential. Okay, for the electric potential, what I am going to write, like V, okay, is equal to 1 by R. 1 by R. So this is a graph. This is a graph for the potential due to a point charge, and for the graph when for an electric dipole. Okay, so just now we have seen for an electric dipole the graph will be V is equal to 1 by R square, or V is directly proportional to 1 by R square. Okay, right. Thank you for watching.